Good day, good day, good day. I hope you guys are good. We've already covered the sequences. Now we want to look at the series. We know that we have the quadratic sequence from grade 11. We know that we have the geometric sequence. We also have the arithmetic sequence. So now we want to look at the series part of it. So the first part is to be able to define what do we mean when we are saying that, okay, we are now looking at the series. So we know that the series is formed when the terms of a sequence are added together. So this means that, for instance, we know that we have these different terms. So we can say, so T1, which is term number 1 of the sequence, T2 of the sequence, T3 of the sequence, until we arrive to Tn of the sequence, are the terms of the sequence, and then the corresponding series now will be, since you say that all the terms of the sequence are added together to make a series, that will be T1 plus T2 plus T3 plus until we arrive to Tn. So that's what we call when we are looking at what we call a series. So making an example, e.g., let's say that we have 5 is to 8 is to 11 is to 14. We know that this is our the difference here is what? The difference here is 3. The 3, which means this is a arithmetic sequence. So we know that this is an arithmetic sequence. So in order for us to have now the series now will just be 5 plus 8 plus 11 plus 14, because when we are looking at a series, we are adding and we are summing the terms together. For instance, let's say an example number 2. Let's say we're given 2 is to 6 is to 18, maybe let's say also is to 54. Then we can see that 6 minus 2 is 4. Then definitely this is like a geometric one. So T2 divided by T1, so that will be 6 divided by 2, and that will give us 3. Then 18 divided by 6, that will give us 3 as well. So there is a difference, which is R 3 3 3 3 3 3. R is equal to 3, R is equal to 3, R is equal to 3, because you know that R is the constant ratio, which is T2 divided by T1, or the forward one divided by the previous one. So we can see that this is the geometric sequence. So in order for us to now have the geometric series, that will be 2 plus 6 plus 18 plus 54. So that will now give us our series. Okay, so now let's look at the first part now. Okay, so if now we want to look into this, there are only 2 series which you guys will be focusing on in this grade 12. The first one is going to be called the arithmetic series. Okay, so the arithmetic series, we have what we call the proof. The proof of the arithmetic series is so important and so crucial because it will be examinable in the exam. So let's look at the proof which we are looking at. Okay, so we're saying that the sum of the first n terms of an arithmetic series with the first term a and the common difference d is given by. Okay, so we know that, let me just write that so that everyone can follow them. So we are saying that the sum of the first n terms, we should analyze that part, it's very, very important. Sum of the first n term of an arithmetic series with first term a, which means a is our first term, okay, and common difference d is given by, this is also going to be on your formula sheet. Okay, that will be Sn is equal to n divided by 2 multiplied by 2a plus n minus 1 multiplied by d. So we've already highlighted it from the definition that, okay, we are saying that this will be the equation to calculate the sum of the first n terms, okay, of an arithmetic series with first term A, which means the term number 1 in that specific series is going to be A, and the common difference between these terms in the series is going to be D, is going to be given by this equation. So for proof now, we can say the proof now, which is examinable to prove this equation. This is easy. So when you prove that, we can say let L be equal to your A plus N minus 1 multiplied by D, and this will be the last term, okay? Then from there, let's just decrease that a little bit to 7. Let's see if that's going to be better. Yes, this is better. Now, we know that Sn is equal to A is the first term plus your A plus D, the second term, plus your A plus 2D, plus until we have now your L minus your 2D, plus your last term minus the D, because that's the common difference which you are looking at, plus your last term. Then again, now we can have another Sn as well. Now we are now starting with this side, which is the right hand side, going back to the left side. So that would be now your last term plus your L minus D, okay, plus your L minus 2D, plus, then now we have our A plus 2D plus A minus D, plus D, sorry, and also plus your first term A over there. So L is the last term, A is the first term. Now we can add these two Sn. So then if we say Sn plus Sn, which means this Sn plus Sn, now we'll end up having our A plus L, then we say A plus D plus L minus D, D and D will cancel with each other. Then you also have plus A plus L, plus, then we say A, let me actually show this part so that perhaps someone doesn't get confused. So we are summing these two. So we're saying this plus this specific series, which we also have here. Then we can see that if we say A plus D, A plus 2D, plus last term minus 2D, we know that this and this will be 0, so we'll be left with A plus L. That's why we have L plus L here. Then the same thing goes again, that will be plus, let's go back, plus A plus the last term, of course. Then again, we have A plus L plus A plus L as we proceed till further notice. So S plus Sn, that will be 2Sn, which will just be equal to N multiplied by A plus the last term, of course, divided by 2 divided by 2, then that will just be Sn is equal to N over 2 multiplied by A plus the last term. But initially we say that L here, we say that our last term is equal to A plus N minus 1 times D. So that will be Sn will be equal to N over 2 multiplied by A plus plus N minus 1 times D, okay, from the previous one. Then your Sn will be equal to N over 2, then multiplied by A plus A, that will be 2A, plus N minus 1 times D. Then after that, this will be your final proof which you have. So you need to know how to prove this. It's easy. Your Sn is got A plus 2 plus A plus D plus 2 plus A plus 2D and going forth. Now, this will be your sum of the terms which we have, and that will be the equation. And also, we can have the remarks as well, which is very important, that if we are given the last term of this series, let's say arithmetic series, then you can use this equation. The sum of the first n term will be equal to N over 2 multiplied by A plus the last term over there. So that's another equation which you can use. So that's a small overview there which we have on the arithmetic series. Okay, this is very crucial and very important for you to understand. Someone might ask, where is this A being the first term? We know that our general term Tn is always equal to A plus N minus 1 times D. So if we want T1, which is the first term, T1 will be equal to A plus, where there is N, we replace with 1 times D. 1 minus 1 is equal to 0. Then times D is equal to 0 there. So we'll end up having our T1 to be A. That's why we can see that here, or that sum, because we are summing the terms which are in the specific sequence. So this is why we have our A. Where are we getting A plus D? A plus D is the term number 2. Say when we say T2, this will be A plus 2 minus 1 times d, because now where there's n, now we are replacing with 2, then that will be a plus 2 minus 1 is 1, 1 times d, it's d, so that will be a plus d, which means this will be your term number 2. T3 again is just going to be a plus 3 minus 1 times d, which is equal to a plus 2d. So as you can see, these terms which we are summing from this point of view, we can literally just see that this is your T1, this is your T2, T3, as we go forth and we go forth. Then that would make your life more easier and more understandable. Thank you so much. The following small video, we have the example based on this.